Hey everyone, thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Simba Khadder, the CEO and founder of FeatureForm. FeatureForm is a feature store, and quickly before we dive into all these details of feature stores, how they relate to vector databases, their impact on RAG and LLM applications, Simba, thank you so much for joining the podcast.
Of course, I'm really excited to be here.
Awesome. And also, sorry, I left this out of the introduction, but I was super impressed by your lecture at the CMU DB seminar. It's going to be linked in the description of this video. Just absolute masterpiece, masterclass on how these systems work. And it was really, really an impressive talk. So maybe to kick things off, we could talk about kind of FeatureForm and feature stores and how they fit in the retrieval augmented generation flow.
Yeah. I think there's kind of a few parts to that. Like, what is a feature store is kind of the first component. What is a feature is maybe even like a more I'll start there. Let me start with what is a feature, and then I'll kind of build up to how I think it fits into RAG. So I'm going to first give the definition of a feature from like a traditional machine learning perspective, which is where we more commonly use the term feature. So in a lot of ML contexts, you'll end up with this raw data set. Let's say you're Spotify and you have a set of listens. You have like users and what they listen to. You want to feed that into some sort of model. Let's say a model that makes recommendations. Now, most models, you can't really just give it raw data. You can just be like, here's my whole data set, learn. You kind of need to take your domain knowledge, apply it to essentially pull out signal from the data. And that idea of like creating signals and pulling signals out of the data, you can call a signal a feature, and you can call that the kind of pulling of signals feature engineering. So features are signal from your data. But in the Spotify example, that might be things like a user's favorite song, their favorite genre in the last 30 days, etc. It could be something as simple as age, or if you're a bank, maybe it's something like how much money do they have in their bank account. So those are features. In the RAG workflow, when I think of RAG, I think of it as a way, you have a context window. It's a finite size. And the goal of RAG is to optimize the amount of information in that window so that the model can make the best prediction possible. Now, when we think about that, when we think of RAG, we kind of go with this really naive first implementation, which works pretty well, which is just take the question, go to a vector DB, get relevant chunks of documents based on that question. It worked pretty well. That's why it's kind of was the first thing and really the first thing people learn. But as we get more sophisticated with RAG, we start to realize that, hey, like there's more than just relevant content. Even like, what does relevant content mean? How do we chunk things? Like, are there different types of pools of content, different types of searches you'd want to do? Or even just like, hey, I'm a bank and someone has a question of how should they split their investments between stocks and bonds. You probably want to know their age. You probably want to know how much money they make. You might want to know what they spend their money on, their risk profile, where they live. Like, there's all these things that you'd want to know about them. And those things are really just features. And they oftentimes don't even live in the vector DB, because otherwise you'd have to kind of take your balance data for your bank and copy that into a vector DB, which is probably not optimal. So yeah, my sense is that that RAG is going to become much more advanced. RAG is going to move away from just it's a vector DB to more how can we get the most relevant information to feed into the prompt. And those things are features, in my opinion. And even the things you get from vector DB, in my opinion, is a feature. And so a feature store is just a way to define these things, to manage them, and to deploy them. They're not necessarily the infrastructure, but it's more the framework to do this.
Amazing. Yeah, I love that perspective on kind of more personalized RAG and kind of thinking of like the recommendation system problem is how you source the context. And yeah, so this feature store thing, I think there's just so much to it. I'm so excited to kind of dive into these things. Can we maybe start off something that I think just maybe introducing you to our listeners a little more is in your talk, you mentioned you built a recommendation system that serves 1 million monthly active users. And I mean, listening to you talk at the CMU series, you are clearly super knowledgeable about all the things. Like you'll say, this is a physical feature store. And then you go like, Uber has this, Airbnb has this. Like you clearly have so much experience with these kind of things. Can you tell me about this kind of career path of building recommendation systems?
Yeah. So my career started. I'll actually take. I mean, most of where I learned when I was back in school, I spent most of my time really obsessed with distributed systems, and that's where a lot of my focus was. The reason why I was so obsessed with distributed systems was because there is never a right answer. Everything is kind of gray. There's always a failure case. There's always heuristics, and I found it's almost like the organic in the sense of like it's much more like building a biological thing than building like a highly engineered thing because it just has to be way more resistant to failure. I just found it fascinating. I just really found the space of hey, like anything can happen, and you need to be able to handle all these cases. It's impossible. There is no like this is the right answer for this problem. Um, so later, it's funny that same kind of enjoyment of the gray area is what got me really into machine learning and very specifically recommender systems. And with recommender systems in particular, what I just really found interesting about them is there's no such thing as a perfect recommendation. Because if you're doing computer vision, I always found computer vision to be boring personally, because there was kind of, it was very like obvious. It's like there's a right answer or a wrong answer. It's really hard, like it's a hard, very, very hard technical space. But I found that like just this concept of it's either right or wrong is to not be as interesting to me. I love the more recommendation style where it's like, hey, there's this idea of serendipity, which is the idea of like sending something to someone that they don't expect that they love and that isn't random but almost is random. But you can't measure that. There's no way to measure serendipity. There's no way to measure kind of the neurons firing in your brain when you see that thing or listen to that song or whatever. Um, so that's why I got into recommender systems. I actually ended up starting a company. I was at Google for a little bit. I was actually a software engineer there for not very long, and I left to start my first company. Mostly because when I was at Google, I felt like I was kind of getting cut into like a maybe like a cog, like the right size piece to fit into this major machine. And I just had all these ideas and thoughts and just things I want to explore. And even like I was on Google Cloud and I had these ideas of, hey, I wonder what would happen if Google Cloud did this, and had product ideas. And they're probably bad ideas. I was like 20, but I still was really driven to like learn why. I just couldn't handle that's not my job. I just have to like not think about these things and just focus on my little sliver in the world. So I left to start my first company, Triton. Triton, we built up, like you said, we were doing personalization, predicting subscriptions, predicting churn for 100 million monthly active users. And most of our customers are media companies, like really large news companies, mix of different things. Anyone doing B2C subscription, really. Um, and when I was there, we were a pretty small team. We were bootstrapped. We were a startup. We did pretty well. I think we served again 100 million MAUs. No joke. And we built all this stuff in house that nowadays we call MLOps. What's really funny is one piece of infrastructure I've probably built 4 times in my career at this point is a vector DB. Now, the vector DBs that we built were much less sophisticated. It was more like, hey, we have Annoy or some other. At the time, it was mostly Annoy. Nowadays, I guess like HNSW. And we essentially, that's great. That's like an in-memory index. But that's like building, it's like, oh, I don't need Postgres. I have a B tree implementation. It's like you're missing a lot to make that an actual database. So we'd kind of hack around it. So I built all kinds of stuff. One thing in particular I built around our platform that was just so pivotal and so impactful for our team was we called it our data platform, but nowadays we call it a feature store. And over time, I decided to open source that, and eventually, in a much longer story of how I did it, I ended up just starting a whole company around it, and that was kind of the creation of FeatureForm, which now would have been January 2020, so like about 3 years ago almost.
Wow. Yeah. So that kind of like ML ops, that like end to end. I think that when I was learning about feature form, that it's such a great example of the ML ops stack from the training. I even love how you have different features for training and inference. You have this unique like batch versus streaming feature problem, as well as the continuous model deployment. I love how you tell anecdotes like with Twitter and how they have like these separate data teams and they're like, hey, could we have our feature? We want these 15 features. And they say, well, all right, give us 2 months. And then you, so I think just this whole end to end, there's so much like system orchestration going on here. Do you mind maybe like stepping into kind of like, I hope it's not like too much of a tour, but kind of like the end to end of the feature lifecycle, I want to call it, and how kind of
Hmm.
these. Yeah.
Yeah, I would love to. So let's. So we've kind of defined a feature. So it's like this signal. Now in practice, like when you first learn machine learning or data science, you're given this beautiful, perfect CSV, and you're told these are the five feature columns, and this is the label. That's it. Like that's all. And now you just build a model around it, and you don't really touch the data. Now that never happens. In reality, the data is really it's just not clean. It's kind of all over. It doesn't have. It's your job to take that and fix it up, clean it up, pull out the relevant attributes, pull out the relevant aspects. But even coming up with ideas of like what, like if again, like the Spotify example, you're Spotify, you're given, users listen to this song. You might come up with all kinds of ideas of like, well, I wonder what the beats per minute of a song is, or I wonder like when it came out, or I wonder what album it's on, or I wonder, there's all kinds of things you can come up with and think about, um, that you can use as features. And a lot of that first step of the feature lifecycle is typically in that data scientist's notebook. They're oftentimes using something like pandas, maybe with a sample of data, and they're just analyzing the data, coming up with ideas, playing around with it, trying to figure out if they can actually kind of siphon this thing out of the data that they're trying to kind of purify out of it. And that's the first step. I'll call it the experimentation stage. There's a lot of problems there. One is maybe not a problem, but just something that's inherent to it is unlike software engineering, where if I tell you to build a vector database, like it'll take a long time, but you typically will have some sense of where to go. You kind of know what your end state sort of kind of looks like. Data science, there it's not really true. It's true like the software engineering versus data science, the engineering versus science is very, very true in the workflow. Data science is way more like you try things, you throw things away. It's just way more experimental. It's way more lightweight. But then you need to get these things in production, and production is not lightweight, and production needs to be very, production ready. And so when we have all these notebooks lying around, they're untitled, we copy and paste between them. We like send CSVs over Slack between teams. It's very common at lots of ML teams where they'll actually write their model in a notebook and then give it to a whole another team, which has to rewrite the whole thing to productionize it. That's kind of what happens today. And so that's the kind of deployment piece. So there's a variety of sets of problems. One is like, how do I deploy this thing? It's really hard today. How do I experiment? How do I keep track of things and organize things? There's no workflow. It's just missing. Collaboration is a lot of sending things over Slack. Monitoring, like once a day is in production, that's not the feature is alive to an extent, right? It changes, it moves, things happen. Like you need to be aware of that. And then finally, governance and access control. Having that fit into a way that isn't just like really painful in the ML lifecycle is really important. And so you have all these things that you're trying to accomplish, but as a data scientist, you work at like I have tables and I have like Spark submits and I have untitled notebooks. So what's missing, what I wish existed when I was dealing with this, was something I literally said like I wish I had Terraform for features. And then being as creative as I am, I said I'll build FeatureForm. And That's kind of the genesis. That's the life cycle, and that's the problem that we aim to solve, is to build almost like a framework above all of this stuff to make it easy to define things, to manage or define features, manage features, and deploy features.
Amazing. So if we could stay kind of in this like end-to-end view before maybe zooming in on feature engineering and zooming in on the inference cache and details like this, I want to. So another thing that really stands out to me is you opened your talk with a slide on saying Kafka, Snowflake, and S3, like how you kind of keep these sources in sync, and that's kind of the opportunity I see between Weaviate and FeatureForm, or vector databases and feature store. Is like this kind of like personalization thing very heavily, where you might search with like a vector that represents Connor, and then you get some features from FeatureForm and use that to re-rank the search results. So I think that kind of, I'd love to understand how because it seems like you blend just so many technologies together. As you mentioned, like the inference cache, you have like Redis in there. So there's like all this kind of orchestration of data systems happening.
Yeah, and we actually support Weaviate. So I have some examples of Weaviate that we've actually done some things I can maybe send you, and you can link in the bottom
Awesome.
if someone wants to get a hands-on view of that. So when you build these features, the features are kind of made up of there's a few abstractions. There's the data sets, there's the transformations, which essentially create new data sets. A set of columns make up a feature. Another set of columns make up a label, and you might have many features in a data set. You might have many different data sets that make up a set of features. And then a training set, which is what you train on, is a set of features mixed with a label. So you need those things in different places. Like features that get served in production need to be in like a low latency cache like Redis. Whereas when you're training, you actually don't want to be serving training features out of Redis. It's not the right tool. You kind of can pre-process that, make a file, like a training file, and then you train off of that. And you want to make sure those things are in sync. So how I see the kind of feature store in VectorDB, it depends on how you define a feature store. There are many definitions. There are three that I've talked through and I've written about. Rather than getting into the differences of all three, I'll just talk about what we do and how we think about it, which we think of a feature store as an orchestration problem. So we're kind of a metadata store and an orchestrator. And in the RAG Weaviate case, the open question is, how do I? So I'm building embeddings, and the embeddings live in Weaviate. And what Weaviate does super well is allow you to look up those, do essentially nearest neighbor lookup on those embeddings, amongst other things. But let's just keep it simple. How do I get things into Weaviate? Like, how do I need to take the text, take the content, take whatever your user behavior, if I have a user embedding. I need to pre-process it. Sometimes I'll have to take features out of it. And then I need to embed it. And the way I embed it, the way I chunk it, all those are variables, right? And I might try different things with different results. So I might end up with many different versions of my embedding table with different chunking, different things. Where's that live? Where's that run? How is that whole kind of workflow managed? That's kind of what's been missing. And we just see a lot of glue. Like people are like, oh, we hack together Airflow, or we have this copy Snowflake table to Weaviate.shell. Like we just have these really ad hoc things. And that's fine when maybe you're just trying one thing out. But when you start to get into iteration mode, especially as evaluation is becoming more and more critical in the LLM workflows, when you're evaluating, you want to be able to be like, cool, that did X good. Now I need to see if I can make it better. So what are you going to do? Well, maybe you'll try different embedding modes, try a different type of chunking. You'll try different documents. Maybe you'll remove documents. There's a billion things you can try. But how do you keep track of all those? Of all those data pipelines, of all those experiments? How can you be sure that when you're doing all that stuff and you productionize it, that you can be really sure it will continue to get updated as new documents come in? There's all these. What's missing is this orchestrator, where Weaviate is like a core piece of infrastructure. Redis for like key value search is a core piece of infrastructure. Spark is a core piece of infrastructure. Kafka is a core piece of infrastructure. But it's almost like if I gave you a Lamborghini and parts, like here's the engine, here's a wheel, here's a steering wheel. Here's a
Mhm.
brake pedal. Here's like a transmission. Here's whatever, a radiator. Um, you're not going to build a Lamborghini if I just give you those things. Especially if I give you some. What you're going to have is essentially some duct tape to like try to fit them together. What's
Hmm.
missing is kind of this like chassis, like this thing, this motherboard that you plug all this stuff into that provides kind of understands what the point of all these things are. Like, oh, I understand what VectorDB where it lives and what it's going to get
Mm.
used for. I understand what Spark is and where it lives and where it's going to get used for. So we're a framework above all that to make it all work together coherently. But we call ourselves a virtual feature store because we don't own, we don't actually store the data. We don't transform the data like in our infra. Like we're not the CPU, we're not the RAM. We're just a motherboard. We just make these things work together correctly and allow you to not have to worry about all the details of how do I copy things over, where do I run things, how do I set up schedules, how do I set up triggers, jobs, etc. Versioning, management, sharing, collaboration. There's all these pieces that come into play.
Yeah, well, I told you quickly going in that I was expecting to get schooled and talking to you, and I hadn't considered when I was looking about Feature Store, I was definitely biased in this kind of thinking about like tabular features and tabular machine learning, and it sounds to me like you've also started thinking about kind of embedding optimization. And as an aside, and I'll come back to the embedding thing. When I was learning about I'm thinking very heavily about like large language model continuous training, and I think you also have and as I was learning about feature form, I was like, oh, they've already kind of solved all these problems. And but with the embedding optimization, I think that so with the features, like it kind of coming back to the thing where it's like, features are signals that help you produce the prediction. And so with the embeddings, I think, most of us are just thinking of, you kind of blindly chunk your text and just give the text to the machine learning model. Are you thinking more about the signals that can go into producing embeddings?
Um, yes, definitely. I mean, our goal isn't necessarily to be the optimizer. Our goal is more to give you a framework to do that yourself. Like, we're not going to decide, oh, you should chunk this way or you should whatever, but just giving you a much easier way to like keep track of all those things you're doing, making sure they run, etc. So you might have a transformation in feature form, which is chunk, and you might have different versions of the chunk thing, and you might try different ones of them for different applications. That's very easy to do. You just choose the name of the one you want to try out. um, that's where it kind of comes into play there. I think of a feature as an input to a model. So a prompt is a feature, an embedding is a feature, analytical your age is a feature. um, so from that perspective, it kind of fit in. Actually, it's funny, building our VectorDB and LLM support took one engineer 1 week because everything else was the same. Um, so it was kind of insane how like it was like 95% of the problem space is the same. The only difference is rather than doing key value lookups, we're doing nearest neighbor lookups. And we have this new thing which is an embedding, but in practice, an embedding is just a vector of floats. The other thing about embeddings is that they've been around for a lot longer than LLMs have been around. I remember the early days where we had, I remember the first time I used an embedding. Well, I use like Word2Vec, but maybe the first time I used a transformer was like Elmo. So I remember like when Elmo was like the really cool hot thing. Um, and then obviously Bert kind of was like maybe the one of the more pivotal models that came out. Um, so embeddings in recommender system, we used to actually feed them into. I mean, I do this for a lot of things. We would feed embeddings as features, like in a model, like in a deep learning model. I would actually one of my inputs would be an embedding without any nearest neighbor lookup. So that was pretty common. Like if I have a user and I want to make a recommendation about for the user, it's really I will pull out a ton of like analytical features about the user, but I might also generate a user embedding, and that user embedding is going to be relatively predictive on you if I build it right. So, um, yeah, these things are much more tied together than I think people give credit for. And the other thing that I believe to be true is that um, I believe that I'm gonna before I tell you what I think, I'm gonna explain why, um, because otherwise people are gonna think I'm crazy. Um, so when deep learning became a thing, everyone was like, "Yeah, I mean, if you're learning anything but deep learning, like it's a waste. Like feature engineering is dead now. Like everything's done. Like all we need is deep learning, and that was a promise, right? And it didn't really happen. Like after years after, like deep learning became a big thing. The most popular model in production was something like XGBoost or Random Forest. Today, I would bet you that the by far the most productionized model that exists is some form of XGBoost. Um, and think that's going to be true in 5 years. Not to say that LLMs aren't going to like. There's a certain set of things like the same way that BERT kind of killed a lot of not killed, but like let's say really made certain branches of NLP um, kind of not as popular because they just don't work as well as BERT. BERT just works magically out of the box. Same as with LLMs. Like there's a lot of places where we would historically build our own models where LLMs just do so much better for essentially free. That doesn't really make sense to not use an LLM. There are certain sets of things that are brand new, like co-pilots, right? Like that was never possible. We never had models that were good enough. But there are so many things where we will just like fraud detection, right? Like fraud detection is not going to be something that we do in LLM. It just doesn't make sense. The economics don't make sense. The just nothing about it really flows. It's not the right tool for the job. Um, and so I believe that all these things, traditional deep learning models, LLMs, and just call them traditional models, will all live side by side. And what's really important, what the core is these are more or less just like expressions of the data. It's like taking your data and making it do valuable things to the user. And choosing the right tool for the job is kind of what the goal is, but the features actually apply across all of them. Because in the end, these are just signals about your data.
Yeah, so I think there's so much to that. The end to end, I guess yeah, so I've been really interested in kind of evaluation, and kind of what led me to Andy Pavlo and the whole rabbit hole of
Yeah.
your research is that self-driving database concept. And so it's kind of like that transforming your features, and not like, I think kind of the way that I had understood this before talking to you is I thought of kind of the ingestion layer to vector databases as like that's all it does, and then the vector database, and then evaluation products like Arise AI or maybe Ragus or Llama Index has products like this. I thought of these as like totally separate kind of things, but if you couple that, how you import and ingest and embed and chunk, and with how you evaluate, and then you connect the whole cycle and to iterate on it, I can see, obviously see a system like that.
I think it's you have to do it. I think that's like because like I mean it's funny because it's just like traditional machine learning. Like with machine learning, like your variables are your features. You have some set of hyperparameters, essentially the model. And I used to break the MLOps platform into four parts. There's the data piece, which I just put broadly is a lot of parts of data, but let's just say everything data. That's where feature stores live. There's training, which is usually where hyperparameter tuning, experiment tracking come in. There's deployment, which is just literally, okay, now I've trained this model, how do I deploy it? There's things like Selden, there's, that sort of problem space. And then finally, there's monitoring, which is now that it's deployed, I need to make sure it behaves correctly. All these things have to be tied together because if monitoring says that the model is misbehaving, the next question becomes why. And oftentimes it's related to the data. And so then, like understanding what data went in, understanding has the data drifted, how is it drifted, um, understanding all that is pivotal, as well as and then you have to train it again, right? So then like having that training be part of it, keeping track of the different experiments you've done, having some sort of training engine. So anyway, I think these things fit together really cleanly. Like that is an MLOps platform or an ML platform. And I think that in LLMs, it's the same thing. Weirdly the same thing. Because now the data part is the same, except now we use vector DBs, we use RAG, we use chunking. It's like the operations we do are different, but it is just other variables. Like what's the inputs or what are the features? Essentially, what's the prompt? But the prompt itself is typically like a chassis where you feed in features, and the features can be a nearest neighbor lookup. It can be, like I said, like an age. It can be a lot of different things. There's the model training, which nowadays is fine tuning. because you're not going to train an LLM from scratch. Deployment, which is a much harder problem for LLMs than it was for XGBoost, because it's just a much bigger model. And then finally, the evaluation monitoring. And I actually think that this is, in my opinion, the funniest part about RAG and LLM applications. I think the most critical pieces are the data and the evaluation. But the data piece, like, you can only get so far until you have evaluation. You need both of them. Because once you have evaluation, but you need the ability to go back and fix things. But the ability to go back and fix things means that you need to have some sort of like almost like a. It's like if you don't have a stopwatch and you're trying to like, oh, I'm trying to make this thing go faster. It's like, I mean, what are you gonna do, right? Just like use your best judgment. Like, oh, it looked fast, you know. Um, so we need some form of evaluation. I think it's an open question. I think we can learn a lot from how recommender systems do evaluation, but I don't think anyone's really figured out evaluation. And I think that's why, in my opinion, there's no such thing in the market today that is an actual enterprise grade LLM application because no one's really figured out evaluation. So everything's more or less a prototype.
Yeah, I guess for me, a couple of things in evaluation that are exciting is again using the language model to like generate synthetic queries, as well as to do that kind of like LLM evaluation of a question answer pair, and you kind of prompt it like, how is this answer? And I feel like those two things kind of close the loop a little bit. With now you have questions, now you have some kind of evaluation, but yeah, I love this kind of entanglement of data and evaluation. I guess like kind of one other thing with the feature engineering that I'm really curious about is, so I love learning about this kind of idea of like my last 30 Spotify songs are this. And you're kind of like, so with RAG, it's like we're trying to give the LLM like the perfect data, but feature engineering is like you're trying to like find these signals and the right way to describe them. Like maybe to tell another story, I remember working on a Kaggle competition that was like you're predicting how many yards they're going to run in a handoff, and so you're looking at like how heavy is the linebacker, just like whatever random thing about the play that you can use to describe the thing. So maybe if you could talk about like feature engineering and then like how you kind of transform your data to come up with some like new view of it. Maybe it's kind of, I don't know if it's quite the same way of thinking about like CDC and materialization in that way of like ETL, getting a new view of your data kind of, but that same kind of idea of like, I multiply the last three handoff plays by is this a defensive player in the game, some kind of combination like that.
I think the example you're giving is such a great way to highlight feature engineering. So let's say I pick a random play in the middle of a football game, and I'm trying to predict the yards we're gonna get. Like that's all I give you. That's the question. Think of all the things you would in your brain process, right? Oh, who's on the field? Who's injured? How have we been doing? Does this look like they're set for a pass play? Have they been doing tricky things? Does this feel like a time they would try to do something big or tricky? Like you would take all of this information in, right? These are all features. And the process of engineering them is more or less just like a PySpark function or something. Like it's not, there's not really much magic there. The things you mentioned around CDC and materializations, these are more the hard realities of actually productionizing this. Like once I come up with like I have a transformation I can write based on this to get all the features I need. Well, then it's like great, but now I need to like serve that to my mom in production that's going to make a prediction on TV, which means that I need to have that thing be constantly updated. I need to have low latency for serving. At the same time, I need to be able to build training sets so I can actually train them. Like there's all these, let's call them hard realities of like the what actually needs to exist. But as a data scientist, what we're trying to do is just allow you to only think about what is the feature, what's the logic. You write that, and then we'll handle the rest. We'll make sure it's run. We'll make sure it is where it needs to be. Like we'll do everything else for you. You just give us the logic you want to exist.
Yeah, and so one more. So I want to just kind of touch on this question really quick before coming back to like materialization and these kind of like database real system kind of questions. Is I'm curious. Like, so I think with language model, a lot of us think like there's no more training is needed, right? And so it's kind of like instead of getting these views of the features for the sake of more training. It's just like for the sake of inference, kind of. And I think you've already been looking at that problem with training and separate training and inference features. I hope I'm not. I'm trying to like keep the separation of the topic flow with the streaming, but like you're already kind of thinking about that difference between training features and inference features. And do large language models change that?
A little bit, yeah, for sure. Because unlike a traditional model, you can just use an LLM without fine tuning it. And a lot of people do. I think what's going to happen is in practice is that people will fine tune and use RAG, like you'll use both. The other thing that happens is it's not training, but think of it as like back testing. So now you're using the training set not to necessarily train the model, but you could use it to fine tune. At the very least, you can use it to back test. If you're changing let's say you're changing your prompt in some way. You're like, hey, actually, I'm adding a few more things. I'm changing my chunking. Think of all the million things you might do to change your prompt in RAG. But now I want to see how it's going to do. Now you could just put in production, hope for the best, right? But that's like, again, nowadays that's literally what people do. But this is why I think that there's no such thing as like an enterprise grade system yet, because in enterprise, if we had a new model with no evaluation metric, we would never just be like, all right, well, let's just see if people like it. We would back test it and we would canary deploy it, and there's a lot of things we would do. So anyway, back testing is one piece. And I actually think that if you're doing back testing, you actually end up in this place where the data you use to back test ends up looking really similar to data you might use to fine tune, especially if you go through the back testing, you find places where it misbehaves, you fix where it misbehaves, and then you use that to even further fine tune the model. So I think the workflow is a little bit different for sure. The difference, like training is a different type of thing. But I don't, it's definitely still relevant. It just looks different. But inference is much more, the interesting thing is in traditional ML, most of the focus is on the training. And in LLMs today, most of the focus is on the inference. But I think that's actually just by nature of the fact that the model just works. It's kind of pre-trained, and no one's, because you're not doing evaluation, you're kind of just like spot testing it, just like ask it 6 questions, have your buddy use it. Do they like it? Okay, cool. I put it in prod. So yeah, that's my sense. I do think it's still relevant, but it's relevant in a very different way. And I think that the evaluation needs to be fixed. I actually don't, just a point you made of like, hey, like we are now using LLMs to like evaluate our evaluation. It's so funny. I get it. Like LLMs are so powerful, but the extreme level of when you have a hammer, everything looks like a nail is so funny. Because let's like really think about that for a second. We're using an LLM to evaluate. That might work pretty well by default. Again, LLMs just work pretty well by default. Zero shot LLMs, unbelievable how good they are. But if I'm evaluating, like even just a simple question of should I use Llama 2 or GPT-3 to evaluate my model? Should I like how can you chart the value in ML? The evaluation metric, the loss function is a function. You can look at it, you can understand it. You can kind of do that with LLM, but you end up in this whole other set where now you might how do you train your evaluation LLM and make sure that how do you evaluate the evaluation becomes the next question. And at least when it's a function, it's a little bit easier to just wrap your head around what it's doing, right? And there is still a little bit of like call it emergent characteristics. But when the actual function is also a model, like when your loss function is another model, I think what people are really doing is they're just kind of like Russian dolling the problem. They're kind of like, well, I'll put another LLM and another LLM and another LLM, right? Because then what I'll do is I'll use a LLM to evaluate my evaluation model to see if it's evaluating correctly. And then it's like you can keep doing that all day long, but you're still not going to get to the end of the problem. You're just hiding it.
Yeah, but I guess like the cool thing about it is that then you don't need to collect as much like data, like feedback data for the result. And I think like my experience with Weaviate is we see a lot of, especially once ChatGPT happened, and then there's just like so many people who are just kind of software engineers, building some new thing like, chat with all of Y Combinator's lectures, and they're these kind of things. And so that's why I think that kind of self-evaluation, it avoids having to have like, I definitely these massive recommendation systems, they have data and they proper ways of evaluating it, but yeah, so yeah, nothing. So and so kind of pivoting topics a little bit, I wanted to learn a little more about streaming features. I first became aware of this with, again, like the tabular data used in symbolic re-rankers like XGBoost, and how you would like if I need Simba's last 10 like the last 10 items you viewed on Amazon, and now I'm going to use that to bias your next search, that you need to have this streaming system. And particularly if we could dive into details about like the log, and kind of like I'm really not an expert on this, so I'm expecting to learn like everyone else, but I'm very curious like what the difference with this is, with this kind of logging compared to maybe like the LSM style logs that are used in databases, and sort of how the problem differs.
Yeah, great question. So rather than calling it streaming, I'm just going to call it time series. And I'll get into where streaming is often used as time series, but it's not required. A lot of people have this problem even if they do batch. Because you might have a feature which you reprocess every hour. So it's in batch, but you still have the same problem space where you still need to like. So the thing with time series, right? Let's say I have a feature, which is your favorite song genre in the last week. And I'm using that as one of the features to make a prediction on what I should recommend to you next. Let's say this week, it's, typically almost every week, it's the Red Hot Chili Peppers or something. But there was some strange week in your life where your favorite genre was Katy Perry. And I need to know what that feature was, not now. I need to know what the feature was at the point in time of my training point. So the way I would train would be like, hey, okay, I know that Connor listened to this Katy Perry song in March of, whatever. And I have this set of features to that my model takes as input. So the way training would work is I would generate those features as they would have been, exactly as they would have been on that date. And then I would use that to train. I would pretty much have it predict, and then I'd compare and see if it guessed right. And if it was wrong, I would then backprop and optimize the weights. So that's one of the core problems, which is I need to be able to generate point in time correct training data. There's another similar problem, which is, let's say I want to build a feature, and that feature is your same thing. Let's say your favorite genre in the last week, and I build that feature now. I need to wait 7 days until I have the first value of the feature, right? Unless I can go back in time and use historical data.
So like introducing a new way to predict that you didn't have in your historical data, but now don't you have all these other problems with just like, XGBoost is like a structured model, and you also have the model problem of adding a new feature to the model?
Kind of. So in the end, right, you're not feeding these models a stream, right? In the end, I'm feeding the model favorite song genre in last week. That from its perspective is just like some value, right? However, I decide to encode that. It doesn't matter. But it's some value. So it doesn't actually know that it's a stream. Most streaming problem, I actually had to talk to someone about this where they're like, hey, what time series model should I use for XYZ? And I'm actually, in my experience, I found of a lot of time series problem. Like, for example, if you are making a model which predicts how much a store is going to sell in a quarter, how much revenue it's going to make in a quarter, I would actually treat that quarter as a single data point. So how much, I would take all these features about that. What season is it? What's, all these things. I would include features from last quarter. So they're still like timed features, but I would include them and I would kind of flatten them into one row. And then when I feed it in from the model's perspective, this is a whole different row. But when I train, it would actually learn the time series difference because the time series, the quarter, and the season would all be features. So yeah, I guess my sense of it is more like the time series problem is tough because of backfill and because of point in time correctness. And the ability to, if I give you a transformation, to run that, not just to get what the value is now, but to be able to run that and get the value at any point in time so I can train my model, is a hard problem. It's not an impossible problem, but if you're a data scientist, like the amount of complexity and just like nuance to get that right is just, not only is it like really hard, even if you could do it, it's like, why are you doing it? Um, it's like much easier if just you give me the logic and FeatureForm goes and figures it out. And so the way we do like how do we do it, which is kind of the log part, um, is that a log. So the way to do it is two steps. Let's just make it two steps. Step one is batch process all the historical data. Step two is start stream processing from where we left off with the batch data. But you want to be able to use the same function for both of those. But, like batch functions typically look very different from streaming functions. But the interesting thing is that pretty much every streaming function can be used as a batch function. So we have you write a streaming function, then we turn it into a batch function, apply it in batch, then continue to update it on the stream. And the way we do that is we create what looks like a log. So every time an event comes in, it's not just, in Kafka, there's a retention period. It's typically, I think, 7 days by default. Kinesis on AWS is a single day by default. So it takes an event, it stores it for up to the retention period, and it goes away. But we don't want that because we need the ability to like go back in time and process those features. So what we do is every time an event comes in, we actually append it to a log, which is really just like, it's like a stack, like an append only thing. You just keep putting them on top. And the magic there is that log is simultaneous. It's almost like that picture of the elephant with the blind men where like all of them say it's something different. If you just look at what's in the log at a point in time, you just freeze time and you look at the log, it looks like batch because it's just this set of rows to process. If you only look at the top of it, it looks like a stream because there's just new events coming in. So the log has the nice characteristic that if you can make something work on a log, you can kind of handle both batch and streaming and unify them, which is just one of the many problems that exist with ML, which is unrelated to ML, right? Like you're a data scientist, like you are learning about things that have nothing to do with the nuance of streaming and logs and data structures. Like you're much more about statistics and pulling out signal and hypothesizing, having domain knowledge. So anyway, that's where all those things come into play.
So it has this understanding. So like if you have I have a stream of everyday sales at a store, and like I want to make the row for 8 days ago, and then when I'm doing that query 8 days ago, if I want to have like the average number of sales I made in the last 15 days or so, I can kind of construct that in the batch sense because I have like this buffer of data that I can use to construct those kind of like aggregation statistics that I then put into one tabular row to make the prediction of, am I going to make this? How many sales am I going to make today? And then streaming features. Okay, so and then I see how you have this point in time where like I need to be able, the data structures need to let me do the average from here back, but I think I'm still missing the streaming features and like what makes it different a little bit.
Yeah, I mean it's not really streaming features as much as it's time series features. But let me maybe let me use that example of the store. So I have a store, and every day at the end of the day, the store streams an event. That event is its total revenue of the day. I have a feature where I want to take that revenue and I want to, let's say, normalize because I have stores everywhere. I want to normalize that revenue to be in USD. Or I want to, let's say, adjust for inflation, or one of a million, like let's say adjust for inflation. So I create my inflation adjustment function. I want to train a model on it. So I'm going to now have that model predict something like, oh, like what happened on, 7 or a year ago.
Mhm.
That event is no longer in Kafka. If it was originally in Kafka, Kafka or whatever, Kinesis, whatever used for streaming,
Mhm.
does not retain events indefinitely.
Mhm.
But I need to backtest my or backfill my training set so I can train my model.
Mhm.
So that means that every time an event comes into Kafka, I simultaneously have to put it into S3. And that's what allows me to create my training set. But there's another point to this, which is when I put that model in production, I want to make sure that I have the most current value of the feature,
Mhm.
the freshest value. The only way to get the freshest value of a feature means I have to be processing events as they come into the stream.
Mhm.
Now, what most companies do is they build two data pipelines. They build a batch pipeline for training and a production pipeline for serving, an inference pipeline. But now you're maintaining and managing two pipelines, and there's many times where they go out of sync, or you change one, and like data science wants to change something, but getting in production takes forever to resolve. Issues of maintaining two different, completely separate pipelines, a completely separate code, sometimes written in different languages. Like one's written in SQL, one's written in Scala. That's pretty common. Um, FeatureForm allows you to just write it once, and we will both handle the batch backfill processing as well as maintaining the up-to-date value as things get streamed in.
Yeah, thank you so much for that. And yeah, I think that's so exciting for this kind of recommendation thing, especially. And yeah, so I've already learned so much from this podcast, but I have to ask you this one more question because I think it's so relevant for with Weaviate. We are looking into this thing called product quantization, where we're compressing vectors, and if there is like a distribution shift, we would maybe want to refit the centroids to compress them. And I know you have some thoughts on like data drift and monitoring, and I would really love to get your perspective because I think we could learn a lot from that as well.
Yeah, I mean, the idea of data drift is it's funny. I'm literally like, I was just teaching someone else about this, and in front of me on my whiteboard, there's like a picture of describing data drift. But think of it like this. Let's say I have a feature which is age. Okay. And let's say that the distribution of users, their age on my training set, it's like a normal distribution. The average age is like 40. For some reason, my app goes super viral with Gen Z. Now, all my features that I'm serving in production, the average age is like 20. Now, the problem I have is that my model was trained on a specific distribution and learned a specific distribution. But my model in production is seeing a different distribution. That might be harmless. Maybe the model is like good enough and generic enough and generalized enough that it can deal with that. But a lot of times it's not. Even just having a warning sign of like, hey, what we're seeing in production, pretty much just these ideas that features change. Another example is when COVID hit. Imagine being Amazon's recommender system. It's like, cool. Now the most bought item is toilet paper. Like for some reason, like yesterday it was I don't know, like a Kindle, and today it's toilet paper. So you can imagine that might, like, the model might not generalize well to that, and it might just start completely misbehaving. So the idea of data drift is more making sure that your original state of things, like this would be common for like streaming different embeddings. I imagine not fully caught up on what you guys are working on there, but let's say you're streaming new items to embed. It might turn out that you end up creating a lot of items that are in a specific set of the embedding space, and that changes the whole distribution of the embedding space, which in practice might cause like different things to happen. So just it's not a bad thing. It might require you to retrain. It might require you to do a lot of different things, but just seeing it before it becomes a problem is a huge value prop that we aim to do.
Yeah, I think 100%. Like this is a really important thing, especially because in our case we're learning the distribution to compress it. So it's like if it changes now, the compression is awful, and so yeah, and the if the age shifts and now you have this new distribution of features to retrain a model, yeah, this whole distribution shift is so fast. It's always been one of these problems with machine learning, and yeah, amazing. Simba, thank you so much for joining the podcast. I think maybe if I could ask you one kind of anchoring question is like, what's kind of on your horizon that excites you the most?
I think what excites me the most, there's a few things. There's a few things. I think maybe the most relevant to maybe the listeners here is seeing RAG get out of what I would consider to be a pretty simplistic, naive approach of just like blindly chunk and embed your documents, do nearest neighbor lookup, throw into a prompt, eyeball it. Does it look okay? That's it. To like really getting much more sophisticated of how we do retrieval and using things, not just vector DBs are going to remain a huge core piece of this, but really using like all the different data you have in different databases, using that, making it all come together and powering LLMs. And I'm really excited for that. I'm seeing it. I'm seeing the way people talk about retrieval change day to day. And I'm seeing people start talking about and thinking about much more complicated ways to do retrieval, which in theory should work better. So I'm really excited for RAG to explode and become way less of this like follow this template, like just chunk and then embed and then nearest neighbor lookup to, hey, this is what you're aiming to do. You're trying to optimize for information. Here's how to do it. And so anyway, that's the thing I think I'm most excited about is like RAG becoming advanced RAG and people understanding that and using that. And that's what I think is going to make LLMs get to the next level. And I mean, Copilot, like GitHub Copilot already does this. And I'm just really excited for like everyone to start to get to that level of sophistication, RAG.
Yeah, well, I've been really impressed with this just kind of like SQL router that takes a question as like vector database query or SQL query, and I think you're really seeing into the future of how much more you could do with that. And yeah, this whole podcast has been really eye opening for me. I was expecting to learn a lot about like the kind of XGBoost for symbolic re-ranking as well as all the system design stuff going in, but now I'm thinking about this whole end to end and how much orchestration can happen with the MLOps and generally how much similarity there is with the feature engineering that has been in place and now for RAG. So, Simba, thank you so much for joining the podcast.
Of course, it was a pleasure. Thanks for having me.